graph of polynomial. Okay, so these are the steps. Apply the leading coefficient test, which is just the end behavior. So basically, does it rise and fall? Find the real zeros. So for the real zeros, remember we let y equals 0 and solve for x. Find the y-intercept. We let x equal 0 and solve for y. And then plot additional points. So the first thing to do is find the end behavior. So the end behavior for this polynomial is going to be, let me just write it out. We need the degree and the leading coefficient. So here I'm going to have, I can rewrite this as 2 times x plus 2, x plus 2, and x minus 3. So if I was to multiply all the first terms here, I get 2 times x is 2x squared. Sorry, 2 times x is 2x, times another x is 2x squared, times another x is going to be 2x cubed, plus a whole bunch of other stuff. But right now we're just interested in the first term, so the degree is odd, which is 3, and the leading coefficient is positive, which is 2. So my behavior is going to rise right and fall left. Okay. Then we want to find the y-intercept. So for the y-intercept, we let x equal 0. And so I end up with 0 plus 2 is 2. 0 minus 3 is negative 3. 2 squared is 4 times 2 is 8 times negative 3 is negative 24. So my y-intercept is 0, negative 24. Then we need to find the real zeros, which are just the x-intercepts. So I'm going to let y equal 0. So I can set each term equal to 0. So I get x equals 3 on this side. And here if I divide by 2, I get 0 is equal to x plus 2 squared, which I can rewrite as x plus 2 times x plus 2. So x is going to be negative 2 and x is negative 2. So at this point, since it occurs one time for x equals 3, then the graph is going to cross. And here, since I get 2 negative 2's, then the graph is going to touch. Okay. So those were the first 3 steps. So I can plot these 3 things or work with these 3 things. So we have at x equals 3, a 0. At x equals 2, negative 2 is another 0. And then my y-intercept is going to be at negative 24. So I'm going to go by 5s here, negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, and so on. So negative 24 is going to be right here. Then we know that the graph is going to rise. So I encourage you to use a pencil first so that you can adjust your graph later. Okay, so here at this point, x equals 3, the graph crosses, so it's going to look something like this. And then at x equals negative 2, it's going to touch and turn. So right now the graph might touch, let's apply the end behavior first. So the end behavior is it rises to the right. So that's going to go up like this, and it crosses, so it comes down. And then to the left, it's going to fall left. So this graph is going to come this way. And at x equals -2, we know that the graph touches. So it's going to be going something like that. Then we need to figure out any other points in between here. So we can choose additional points. That's step number 4. And to figure out exactly what happens with the graph. So I'm going to use -1 and +1 to figure out extra points. Okay, so extra points to make our graph better. So f of -1 would be 2 times -1 plus 2 squared and 1 minus 3. So f of -1, if I evaluate it, comes out to -8. So at -1, I get -8, which is maybe around here. Okay. And then let's look at f of 1. So f of 1 would be, plug it in, 2 times 1 plus 2 squared, 1 minus 3. So f of 1 is 2. 2 plus 1 is 3 squared is 9. And 1 minus 3 is -2. -2 times 2 is -4 times 9. F of 1 is -36. So f of 1 is going to be down here somewhere. And then we can try 2 just to be sure. And that comes out to -32. So f of 2 is going to be a little bit higher. So maybe like right here. And so now we're ready to complete our graph. So our graph is going to go here. It's going to touch, come down, and then go up. Okay. So let's try the last one here. So we have the next one. We can look at the end behavior. So again, for the end behavior, the options, remember, is you can have x squared, something that is behaving like x squared. Maybe it behaves like -x squared, or it behaves like x cubed, or it behaves like -x cubed. So in this example, our degree is 3, which is odd, and our leading coefficient is 1, which is positive. So the behavior is going to be like this here. So we can say that the graph rises right and falls left. Okay, so that's for the end behavior. The y-intercept, we let x equal 0. So anywhere you see an x, we plug in 0. So g of 0 is going to be 0. So my y-intercept is at 0, 0. The x-intercept, or the zeros slash x-intercept, they're both the same name. We let y equal 0. And solve for x. So here they have an x squared in common, so I can factor out an x squared. Factoring out an x squared from x cubed leaves me with x and 3. So I get 0 is equal to x squared and 0 is equal to x minus 3. So I can rewrite this as x times x. So x is equal to 0 and x is equal to 0. And for x minus 3, we get x equals 3. The multiplicity of x equals 3 is 1 because it only occurs one time, which is the multiplicity of 1 is odd. So that's going to cross. And x equals 0, the multiplicity is 2, and 2 is even. So it's going to touch and turn. So let's plot what we have so far. So we have our y-intercept is at 0, 0. Our x-intercept is at 0, 0. And then we have x equals 3. Okay, so we have these 2 points. Again, I like to use a pencil just to sketch the graph briefly. So my behavior rises to the right, so this is going to go up over here. And it falls left, so this is going to go down. At x equals 0, it touches, so that means it's going to touch and turn. And at x equals 3, it crosses. So it goes something like this. So we need to figure out what's happening in between these 2 zeros. So I have 1 and 2 that I'm going to use as my extra points. So if I use 1, then we get g of 1 is equal to 1 cubed minus 3 times 1 squared. So we get 1 minus 3 equals negative 2. So negative 1 or positive 1 gives me a negative 2 right here. And then I'm going to use g of 2. So we get 2 cubed minus 3 times 2 squared. So 2 cubed is 8, 2 squared is 4, times 3 is negative 12. So we get negative 4. So we go 1, 2, 3, 4. So now I can use this information to plot my graph. So I'm going to go from this point here, will come down, and then it's going to go up. Let me erase the pencil. And so that would be our sketch for our graph. Okay, so that's the end of section 2.2.